Robotic devices are typically used as a cost-effective alternative for repetitive and labor-intensive operations when manufacturing, inspecting, packaging, and transporting products. In most cases, robots require end-of-arm tools to grip, move, or alter the product. Having an optimized end-of-arm tool is critical to maximize operational productivity and savings while eliminating product damage. Frequently, custom end-of-arm tools are either time or cost prohibitive, so companies are forced to settle for non-optimized stock tools that are not designed to conform to a product's shape. With FDM, custom end-of-arm tools are accurately created directly from CAD data in stable, durable, and lightweight thermoplastic. These end-of-arm tools are produced in-house, quickly, affordably, and hassle-free. Companies can realize savings of 70 to 85% in time and 75 to 85% in cost, all while reducing weight by 50 to 80%. FDM end-of-arm tools increase performance by providing lightweight, low-mass tools that decrease process cycle times and increase payload capacity. What's more, FDM makes a non-marring tool that has impact-dampening properties. In addition, tool designers have more options that will allow for integration of components such as magnets, integration of vacuum ports, and reduction of the number of components in the assembly.
3D printing allows us to quickly go from design stages to an actual production-ready part as fast as possible. It's much faster than getting one machined, and it's much more cost-effective than getting one injection molded in the quantities that we deal with.
With the use of the FDM material, it allows our designers to think outside of the box a little bit more and produce something that's specific for the application versus having to design around the manufacturing environment. It allows quite a bit of flexibility for them to be able to do that.
Leading companies are utilizing FDM technology to produce end-of-arm tools optimized for the tasks they perform, all while reducing time, cost, weight, and maximizing robot performance.